Okay, shall we start now? And write down example number 8. Write down the question. The velocity and acceleration. The velocity and acceleration of a particle at t is equals to 0 second. At t is equals to 0 second. U is equals to 2 I cap plus 3 j cap, and acceleration is equals to 4I plus 2 j cap, 4I plus 2 j cap full stop. Find velocity and displacement at t is equals to 2 seconds. First use v is equals to u plus at. Then apply those equations. You have u, you have a, and you have also t. Then apply s is equals to ut plus half at square. Then calculate and tell me this. Or you can apply v square minus u square is equals to 2as. Whatever you feel easy, you can apply and tell me the answer. Okay, shall I now? So v is equals to u plus of at. V we don't know. U 2I cap plus 3j cap plus of acceleration 4I cap plus 2j cap into time, that is 2 seconds. So v is equals to 2I plus of 3j plus of 8I plus of 4j, or v is equals to 10I cap plus of 7j cap. Similarly, we can also calculate what? Magnitude. If the question is asked about the magnitude, calculate the magnitude also. Then we can say under the root of 10 square, that is 100, plus of 49, that is nothing but under the root of 149 meter per second. Similarly, calculating the displacement. So s is equals to ut plus of half at square su 2I cap plus of 3j cap into time is 2 seconds plus of half into time, that is 2 into acceleration 4I plus of 2j cap. Can I cancel this 2 and 2? Or s is equals to 4I cap plus 6j cap plus of 8I cap plus of 4j cap. So s is equals to 6, 10, and this one is 12. So 12I cap plus of 10j cap. Similarly, if they ask the magnitude to calculate, then this can be written as under the root of 144 plus of 100, that is nothing but 244 meters. How many of you got these answers? Okay, very good, very good. So majority have you understood that how to find, even if they provide in vector forms. Okay, write down. Okay, example number 9. Write down. Write the question. Velocity of the particle at t is equals to 0, at t is equals to 0, u is equals to 2 meter per second. Full stop. The next, a constant acceleration of a is equals to 2 meter per square second acts on a particle for 2 seconds. comma, at an angle of 60 degree, at an angle of 60 degree. That means, can I say acceleration is acting at an angle of 60 degree on the particle when initial velocity is 2 meter per second. Then full stop. Find the magnitude of velocity. Find the magnitude of velocity and displacement. Find the magnitude of velocity and displacement at t is equals to 2 seconds. At t is equals to 2 seconds. Okay. Stop writing and just listen to me now. What is given now? At t is equals to 0, initial velocity is 2 meter per second. Let particle is at this point. Let this be origin. And velocity is along x-axis, that is 2 meter per second. And can I write this as 2 cap? Can I? Okay. Then this is happening at t is equals to 0 seconds. Now acceleration is also acting on that body, that to be 2 meter per square second, but at an angle of 60 degree. That means if the body is at the origin, acceleration is acting in this direction by 2 meter per square second, making an angle with the velocity that is 60 degree. Got my point? How they frame the question. Initially, body is here and body is going in this direction at t is equals to 0, that 2 meter per second. And acceleration is acting with an angle of 60 degree with the velocity. Okay. The next thing, they ask you to calculate what? Velocity, magnitude of velocity and displacement at t is equals to 2 seconds. So we have acceleration, we have initial velocity, and we have the theta. And this theta can be having the component in this direction, that is ax, and this ax is nothing but 2 cos 60 degree I cap. And in this direction, ay, and ay is nothing but 2 sine 60 degree j cap. So can I write acceleration is nothing but ax plus of ay, or acceleration is nothing but 2 cos 60 degree I cap plus of 2 sine 60 degree j cap. Okay. Acceleration can be written as now 2 cos 60 1 by 2 and this 2 get cancelled. So I cap plus of sine 60 degree, that is root 3 by 2, 2 get cancelled. Left out is root 3 j cap. So this is your acceleration. Then what is your initial velocity? U. U is along I cap. So you have A, you have U, and you have also having the time. So calculating V. So V is nothing but U plus of AT, or V is equals to, substitute and tell me the answer, final answer. Similarly, then calculate for S. S is equals to UT plus of half AT square. Okay, calculate and tell me first. Okay, shall I now? So what is your U? U is 2 I cap plus of A is I cap plus of root 3 j cap into time is 2, or V is equals to 2 I cap plus of 2 I cap plus of 2 root 3 j cap, or V can be written as 4 I cap plus of 2 root 3 j cap. Similarly, S is equals to half AT square, and U is what? 2 I cap into 2 plus of half into acceleration I cap plus of root 3 into how much? Time, that is t square 4. Can I cancel this once and twice? Or S is equals to 4 I cap plus of 2 I cap plus 2 root 3 j cap. Or S is nothing but 6 I cap plus of 2 root 3 j cap. Substituting in mod, So V is nothing but under the root of 4 square plus of 2 root 3 square, or S is nothing but under the root of 6 square plus 2 root 3 square. Solving that will provide you the answer. Right on. Okay, now listen to me. They can provide you velocity in also in the form of acceleration. Okay, for example, they can provide you velocity making an angle with the horizontal, that is 45 degree, and object is going with a velocity, initial velocity u is equals to 2 root 2 meter per second. Okay, and on this body which is at the origin, consider the body is at origin, acceleration is also acting. Now acceleration is acting at an angle of, that is 2 meter per square second, making an angle 60 degree. They can provide you like this also. So all you need to do is what? Take the component, and u component can be written as over here 2i cap and over here 2j cap. So this is your ui, this is your ux, and acceleration ax can be written as in this direction, that is 2 cos 60 degree I cap, and ay along y direction, that is 2 sine of 60 degree j cap. Okay, then again what you need to do is, that is u is nothing but what? Ux plus of uy, or ax a is equals to ax is equals to ax plus of ay. All we need to substitute in this form. They can change anything na beta. All we need to know how to do the answer. Okay, you can apply n number of values, you can frame n number of questions. So if you have understood the subject, when I can say that you have understood the subject, if you are framing the question on your own. Day before yesterday I told you that if you understood how to frame the question, that means you have understood the concept. Okay, now if you want to write, you can write this also. Okay, shall I? Example number 10. Now I think in last sheet you said that reaction time, one question is given on reaction time now. So let us discuss on that today. For example, consider this as a straight road. On the straight road, a girl is standing here. Okay, and she is PP. Papa's Pari. Now, consider, and one more girl is riding a car. Okay, at t is equals to 0, this car is moving with a velocity of 100 meter per second. Okay, and given that the distance between the initial position of the car and the girl, let it maybe 800 meters. 800 meters. And this car is having a capacity of braking, and you will be hearing the word of maximum braking or deacceleration. So when she saw a girl who is driving the car, saw the girl, and she was still thinking, should I put the brake on or should I put the indicators on to stop the car? Okay, now so the girl want to stop the car, so she took a time period of, consider, 1 second to decide whether to put the brakes or not. So this time what she is deciding is called as reaction time. Reaction time is nothing but she is still thinking to put the brake or not. She is still want to prepare herself to put the brake or not, or by putting the right hand side indicator, she can stop, or she can also stop the car by putting her leg on the road. Na? Yes or no? Yes. Very good. So, all we need to calculate is, at what point did the car stop? They can ask like this: from origin, at what distance the car stopped? Or they can also ask you, what is the distance between the car and the girl when the car got stopped? If given the acceleration is having a maximum value of 10 square meter. Okay, this is the braking limit. They can use the word braking limit, maximum braking effort, or braking force. If mass is given, they will use the word braking force, that we'll discuss in laws of motion. Okay, now, till now, acceleration is here. That is minus 10 meter per square second. Body didn't stop. That means from here to this position, she is still thinking whether to put the brake or not. Okay, that particular time is called as what? Reaction time. Now, that means if she is not putting the brakes, that means there is no deacceleration. At this point, there is no acceleration or no deacceleration. That means body is traveling with constant velocity. If constant velocity means from here to here, can I say A is 0? Okay, let this point is as name A, B, and wherever it stops, we will put that C. Okay, distance traveled by AB. S is equals to V into, can I say, time. How much time she is taking to decide still? 1 second. And what is the velocity at that point? We have taken 100 meter per second. Na? So distance is equals to 100 into time. S is equals to 100 meter. So this is the distance. This is the distance from origin, or from t is equals to 0 position. And she traveled 100 meter. After 100 meter, she put what? Braking. Okay. So once the braking started, and the braking limit is given what? Acceleration is equals to 10 meter per square second. So from B to, let's say, body stopped here. We don't know. Let's say. Now, from 18 already 100 gone. 100 meter is gone now. Okay. If our answer is equal or less than 700, she is okay. If our answer from B to this point is greater than 700, then 100% there is an accident. Okay. Now, so let this point is C, and at point C, we are imagining velocity is equals to 0. You can take C here also. Maybe there, maybe on the girl, maybe beyond the girl. But we are taking just a point where the body is getting stopped. Okay. So final velocity minus of initial velocity is equals to 2as. Final velocity, we are saying that body should be stopping. So stopping means 0. Initial velocity is given how much? 100. So 100 into 100, which is equals to 2 into acceleration is given how much? That is 10 displacement. We don't know. Okay, one negative get cancel. 2 1s are 2 5s are. So S is equals to 500 meter. 500 meter from what point? So from here to here. B to C, 500 meter. If the question is asked, at what distance the body stopped from the original position, means I can say that 600 meters. Or the question can ask you like this: what will be the stopping point or the distance between where the body stopped or the car stopped and the girl? Then I can say this is what? 200 meter. Okay. Now one more thing you need to remember: whenever reaction time is given, whatever the velocity with which the body is moving, you should be considering that only. That is happening. Reaction time is before putting the acceleration. Acceleration, that is negative acceleration, and negative acceleration is nothing but before braking. Before braking, body is moving with constant speed or constant velocity. Got my point? Right on. Okay, example number 11. And given that acceleration along x-axis is 6 meter per square second, acceleration along y-axis is given 6 square 36 64, that means 8 meter per square second is given. Okay, now write down the question. If ax is equals to 6 meter per square second, if ax is equals to 6 meter per square second, and ay is equals to 8 meter per square second, if the body is starting from rest, from origin, we'll stop. Find the distance traveled. Find the distance traveled from origin at t is equals to 4 seconds. Karo. Okay, shall I? Just now I told you that A is equals to AX plus of AY, and this should be written as under the roots. We are calculating the magnitude now. So A is equals to this 36 square plus, 6 square 36, 8 square becomes 64 under the root. This becomes 10 meter per square second. So acceleration is 10 meter per square second. We have initial velocity is 0. We can find v, and v is nothing but u plus of at. Initial velocity is 0. So v is equals to acceleration, that is 10, and t is how much? 4 seconds na. So t is given 4 seconds. Okay, so t is equals to 4 seconds. So that is velocity is equals to 40 meter per second. Substitute in v square minus u square is equals to 2as, or s is equals to ut plus half at square. Whatever you want to substitute, you can substitute and get the answer. So s is equals to ut plus of half at square. Initial velocity is 0. So s is equals to half into acceleration 10. Time period, that is 16 1s 5. S is equals to 16 5s 80 meters. किसी का आया था आंसर? Okay, now listen to me. What is the question? Sheet number 2, acceleration, question number 14. So sheet number 2 of acceleration, and question number is 14. Now listen to me. I understood the question. No need the question. They can provide you. Now listen to me. For example, this is the total path. A to B, then C, then D, similarly E. Okay. Given that U is equals to 0. U is given 0? Yes. If U is equals to 0, then and then only that is applicable. And if U is not equal, then what is applicable? I will tell you this. For example, A is constant. Given that A is constant, they can use the word A is equals to constant, or they can use the word A is equals to uniform. Uniform acceleration and constant both means same. Okay. For example, what is our formula if initial velocity is 0? S is equals to ut plus of half at square. Okay. As we all know that velocity is increasing per second. Acceleration is nothing but velocity per second, na? So how much velocity is increasing with Seconds is nothing but acceleration. If I say 0, if acceleration is 10, that means velocity here will be 10. At this point, velocity will be 20. At this point, velocity will be 30, so on. Okay. That means, can I say that this distance is S1, this distance is S2, and this distance is S3, and this distance is S4. Which one is greater? S4 will be greater. Why? Because it is traveling more distance in same interval of time. Let the time period is 1 second in each. Okay. Now, for example, if 1 second velocity is 10, that means it will travel 10 meter. Here can I say 20 meter? Here can I say 30 meter? In general, can I say that in every step, consider these are the steps. In every step, distance is increasing because velocity is increasing. Generally, if I consider this to calculate, can I say this becomes 0? This becomes 0. So S is equals to half of acceleration, let consider 10, time consider 1. So distance is how much? 5 meters now. Similarly, consider for A to C. A to C now. S is equals to, again U becomes 0, that means UT becomes 0, left out is what? Half AT square, or S is equals to, let this one is S1, this one is your S2. Just for consideration. So half acceleration is still 10, I am saying, and time period it took 2, and this becomes 2 square 4. So S is equals to how much it traveled here? Can I say 20 meter? How much it traveled here? 5 meter. How much it traveled here? 20 meter. Okay. Similarly, take time t is equals to 3 seconds. So S is equals to half into 10 into 3 square, that is 9. So 2 ones, this is 5. S is equals to what? 45. Okay. Now, so 0 to first 5 meters, then 20 meters, then from here to here, then next is 45 meters. Now, how much it is increasing in every second? Can I say between T2 and T1 it increased by 15 meters? Ye dekho, this is 15 meters. Yes or no? And between this and this, can I say that it increased by 25 meters? Is it increasing? Yes. Then we have a shortcut to find all these without doing multiple steps. If U is equals to 0 and A is equals to constant, U is equals to what? 0 and A is equals to constant, then we write S1 is to S2 is to S3 is to S4, so on, is equals to 1 is to 3 is to 5 is to 7 is to 9, so on. Got my point? This is only applicable. That means S1, S2 or S3, if we are discussing for only 3, which is equals to 1 is to 3 is to 5. This is only applicable if U is 0 and A is constant. Then this can be written as S is equals to half AT square 2n minus of 1. Half AT square 2n minus of 1. So where n can be written as 1, 2, 0, so on, integers. Okay, now S is equals to ut plus half at square, ut gone 0, initial velocity is 0. If I substitute n value 0, so 2 into 0, 0 minus of 1. If I substitute 2, so 2 into 2, 4. 4 minus of 1, 3. It increased 3 times. So first is what? 1. Then what? 3. If I substitute 3, 2 into 3, 6. 6 minus of 1, 5. So if I substitute 4, 2 into 4 minus of 1, that is what? 7. So on. If U is not 0 but A is constant. If, इधर लिख देता हूँ. If u is not 0, but a is constant. A is what? Constant. Then the same equation can be written as s is equals to ut plus of half at square, again 2n minus of 1. But here s1 is to s2 is to s3 is equals to, not equal to, sorry, 1 is to 3 is to 5. I got my point. So 1 is to 3 is to 5 is to 7 is to 9 is to so on is only applicable if initial velocity is 0 and acceleration must and should be constant. Got my point? Okay. And if u is not 0 but a is constant, then we can substitute like this. But all you need to substitute ut here. Aaya kya? Okay. Let us try to understand with by example. Write down this first. Okay. And your question in that sheet, that is question number 14, is percentage of increasing distance, na? Percentage of increasing distance. For example, what is the instance given? 3 to 4. Okay. Now, S1 is to S2 is to S3 is to S4. This can be written as 1 is to 3 is to 5 is to 7. Okay. Can I write S4 by S3 is nothing but 7 by 5. S4 upon S3 is nothing but 7 upon 5. Okay. Whatever the value they can give. They can ask you 10th and 3rd, 10th and 9th. They can. So whatever the value, the maximum value by the lower value. So S4 upon S3 is 7 by 5. This is your S4 and this is your S3. Now, S4 by S3 is equals to 7 by 5. But he is asking you the percentage, na? Percentage. So whenever the percentage is asked, then S4 upon S3 minus of 1 into 100. That will provide you the percentage. In reality, we should be writing this as S4 minus of S3 divided by S3 into 100. Difference of distance divided by the asked distance into 100. Or you can also write this in this form. Or percentage can be written as 7 upon 3 minus of 1 into 100. So this becomes how much? 4 by 5. Sorry, 5 hai na? 4 upon 5. So percentage is equals to, this will be 2 upon 5 into 100, or once this becomes 20, that is equals to 40%. Okay. Now, any other doubt? Okay, shall I now? Same sheet number 2, acceleration, question number 14, 19. Okay, now we have an equation like this. Sn is equals to u plus of a by 2n minus of 1. We have this equation now. What did I told you? This n is nothing but time. This n is nothing but time. And the question is, can we apply this equation for 0.7 seconds? Right now, can we apply this formula for 0.7 seconds? Now, while deriving, we separated the distance, time. So 5th second minus of 4th second will be providing you the 5th, nth value, na? Okay, now, if I substitute 0.7 in term of n, okay, yes or no? Yes, that they asked. Can 0.1 we substitute in n value? We cannot. First thing, what is the maximum time period we are having? Anything. And what is the least? 0 to 1 second. Yes. So n value, time cannot be negative, first thing. Time cannot be negative. If I substitute 0.7 minus of 1, then it becomes 0.3 with the negative. Is it possible to have time like this minus? No. Okay. So this formula is only applicable for t is equals to, either it should be equal to 1 or it should be greater than 1. Okay. Anything else? No, no? Okay. We will discuss tomorrow by the graph question. There are some graphical questions we need to discuss on displacement and acceleration. We will discuss that by tomorrow. Okay.